Okay, this is gonna be a quick build vlog. I don't think it's gonna be quick though. So I have this VzBot gantry just lying here for the past almost 6 months. 6 months. This is VzBot 24 serial. It's a VZ330 that was converted from a Tronc CX5SA. And then I recently needed a laser cutter for cutting like Delrin. So a lot of people use not where is it? There's a lot of Ender laser cutters, these ones. But these are I want it to be faster and I don't have an Ender. So I'm thinking about getting a laser cutter like this one. It's a 20-watt laser and then just mounting it onto there. It shouldn't be that hard. It shouldn't be that hard. So I have the design here basically. That's the mock-up of the laser. And then this is just bolted on. I modded this top plate for the print head. And then just these two plates that help bolt onto the laser. I have the revisions here. This was the first revision. This was pretty skinny on the side. So after printed out, it kind of flexed a bit. So you can see on the newer revisions that it's much more bulkier. And then once I added the ribbing, I also, in the last revision, toned it down a bit. I don't know if you can see there, but the holes are easier to access on the second revision to the left. And then so we have all the revisions here. And then we should be good. So this is how I plan to mount the thing. My main concern right now is if the MGN and especially the carbon fiber are built to handle that amount of torsional stress. See the carbon fiber there. I don't know if it's shown up too well. There it is. So that's an MGN 9 rail and that's carbon fiber composite. So they weren't built to handle torsional stresses like this one, especially because this compared to like an Ender, because Enders are on V rollers. And then this print head is supposed to distribute the weight pretty evenly on both sides so that there's not substantial torsional stress. But this is massive, and it's all going to be hanging off the front. So, if you look at the Highwind data sheets for this thing, MGN series rails, these are MGN 9 rails. So, here, 9H. 9H, we want to be looking for MR, which is I don't know what it stands for. Rotational stress, rotational torque, something like that. So, torque is force times radius. And the force applied is just going to be the mass of the diode. So let's see how massive this diode is. This diode is too far. Is 680 grams. I had it highlighted. 680 grams. So 680 grams. Let's see. It's gonna be pretty evenly distributed down the middle. So this diode is. Let's see how wide it is. So this edge to this edge. That's 66 millimeters, so 3.3 centimeters, halfway. And then from this point to this point, that's 2.6 centimeters. So that's around 6 centimeters total from the center of the rail to the center of mass of the force exerted. That's pretty much it. So if you do the calculations, I have it down somewhere. Actually, I don't. So it's going to be 0.06 meters, because it's Newton meters, times 0.6, I think it's 0.68, and then we want to times gravity, which is 10. So 0.4, that's the torque, that's Newton meters. We have the distance in meters, we have the force exerted by the diode. So 0.4 Newton meters, is that correct? Because the MGN 9H over here is rated for 19.6 Newton meters of rotational torque statically. And this is static because we're not actively applying it. I think that's what that means, right? Yeah, I think it is. So I think we should be fine. I don't know. I feel like my calculations are off or something, because that is a way bigger difference than I was expecting. Okay, so if the rail can handle it, then the question would be if the carbon fiber can. I guess we'll have to figure that out later. We can always go to an MGN12. That's 38 Newton meters. That's probably more than enough. That's double the MGN9. Yeah, I think we're good on that. So right now, today's plan is to repair this, get it into a working gantry. Maybe put belts or two of it. Take apart the current EVA hot end, that's EVA mount that's on there, and look into electronics for this thing, because right now it's not wired at all. And this is gonna be just two motors running at 24 volts. I don't think we need to go 48 volts TCM 5160s on this. That's overkill for a laser cutter. And then for safety is also a really big thing. So I designed, I put a bottom enclosure on this thing. I'm planning to make this out of, I don't know, wood or something, like 2 centimeter thick MDF, because the laser is only dangerous. Well, it's dangerous, but it can't cut through the wood if it's on this side if it's not focused enough. But then wood is also a fire hazard. So maybe I'm gonna put sheet steel on this thing, because I know the proper laser absorbing panels are expensive. So I only want to have one of those for a viewport. But everything else, I think sheet metal is the way to go. And then for the top cover, I just borrowed the standard one from the VZ330. The good thing about this design is actually that I don't have to buy any more extrusions, because we're only using 1/4 of an extrusion for the legs, and we can use the rest for the top cover, since I don't have a top cover currently. But then I would have to modify it to use 2040s on the top instead of, I think they have 2020s right here. Yeah, that might be a bit of it. Yeah, no, that's going to be hard. That's going to be hard, because they have 2020s on this top cover, but I have 2040s. And then they slot into the motor covers, into the motor mounts. I think you could move this a bit, and then I think it's possible. That one's definitely possible. You could just cut it out more this way. For this one, I'm not so sure, because this is pretty tight both ways. This is pretty tight both ways. Yeah, I'm not sure about that. You would have to remove this screw, but then after you remove that screw, I guess if it's just a laser cutter, I don't need that much power. I could probably get away with removing that screw. This is going to be sketchy already. I could just order more 2020 extrusions, because I need the top one, so I can't cut them. This one I could just also do that. And then for the back one's easy, because the back one there's space here, I think. Yeah, so that's the plan. I'm gonna print out these motor mounts and get the gantry back up and running, and then we should be good. So this is day one of laser cutting, of building a laser cutter from a VzBot. Hope it goes well.